I'm Anil Kumar. Welcome to my series on preparation for admission to the best universities. We have taken questions from previous test papers of some entrance examinations. Here is question number one, which is from XAT, Xavier Aptitude Test 2019 test paper. A gold ingot in the shape of a cylinder is melted and the resulting molten metal molded into few identical conical ingots. If the height of each cone is half the height of the original cylinder and the area of the circular base of each cone is one-fifth that of the circular base of cylinder, then how many cone ingots can be made? Right? So the concept here is that the volume remains same. We have to find the number of cone ingots. You can always pause the video, answer this question, and then look into my suggestions. So as far as the cylinder is concerned, we know that the volume of the cylinder will be pi r square h, right? Let's take capital letters here. As far as the cone is concerned, so let's say volume of the cone, let me write cone here, will be pi r small h, and the volume of cone is always one-third the volume of the cylinder. So divided by 3. Now we are given that if the height of each cone is half the height of the original, that means we have capital H is 2 times H. That is first condition. And the area of the circular base of each cone is 1/5. So area of the circular base is pi r square. So that means we could write pi capital R square as 5 times pi r square. Does make sense to you? Correct? So these are two other conditions which are given to us. We need to find the number of ingots, right? So what we are saying here is the volume of cylinder is equal to n times volume of cones. Correct? Since we make n cones out of the whole melted cylinder. So volume of cylinder here is pi r square h, and the volume of cone is n times pi r square h divided by, let me write 3 here. Is that clear? This is what it is. We need to find the value of n. So you know some relations on this side. You could use these relations and straight away get the answer. So let's write down. So we'll write pi r square is 5 pi r square, right? So instead of pi r square, we'll write 5 pi lowercase, right? And capital H as 2h times 2h equals to n over 3 pi r square h. It is actually simpler if you write in the product form rather than lowercase h as equals to capital H divided by 2. This is much simpler approach. See, clearly you can cancel many terms now. Do you see that? So cancel whatever you can. So all those unknown variables, they got cancelled. You want to find n, so you can multiply this here and get your result. So you get 5 times 2 times 3 as the value of n, and which is 30. So we get 30 as the value of n. So I hope you find these steps simple and easy to understand. That's the whole idea, correct? So n is 30 for us. Option C is the right option, correct? However, if you are not supposed to show the solution, in that case, you could also think geometrically about this relation, right? So what we're talking about is we're talking about a cylinder, right? So let's say that is our cylinder. So, so in a cylinder, we are finding volume of a cone. So when we say cone, we know the volume is 1/3. So we can divide it into three equal parts. Correct. So every cone we get three parts. Now we also know that the cone which is being produced is half the height. So half the height means you could divide it into half. Correct? So each cone is half the height. Now we are saying that the area is divided into five parts, right? So now we are given another condition which says area is into five parts. So here we have five parts of each, right? So we have 5, 5, 5, 5, and 5 and 5. Do you see that? So five parts, you can now count the number of cones, which are 5 times 6, and you get your result 30. Without calculation, in an aptitude test, you could think like this and provide a solution. So that should be another approach for solving this question. I hope that makes sense, right? So feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.